ahead.
Are we live? Okay, because usually it takes a little while. Cool. Thanks everyone for being here tonight. BT is going to tell us about DynamoDB and how he uses it in his serverless projects. I'm very excited. Thanks for Neil and for Laurik as well, and for Tangent Solutions. It's the building that we are in right now. Thank you very much for the refreshments. We have some swag over there. So after the meetup, we can do some networking that side, and there will be some pizza. If you haven't already gotten something to drink, you are welcome to get something there. And I think that's it. BT, you can take it away.
Thanks. Hi everyone. I've been bothering Rian about this because I've become a very big advocate for DynamoDB, and I work on a lot of projects using it. So I thought it might be a nice opportunity to share. But before that, let's get the admin out of the way. I'm VT. People usually ask. My full name is Vutlari Rikotso, and that's exactly why I go by VT. It's easier for everyone. About me, not really much to tell. I'm a principal consultant at Dimen. Dimen is a UK-based consultancy. So principal consultant, think of principal engineer, but expected very much to interface directly with the client, provide more of an overview of the solution more than just building. I'm also 1/3 of the ZA Tech Radio podcast. More ZA Tech Radio. So ZA Tech Radio is something I started with two of my friends, Stu and Sihle. We've got a podcast. You can access it on our website, Spotify, or whatever you use, like Apple Podcast. We just talk about our opinions about the tech state of the world right now, with a special focus on South Africa. And when I do find some time, I'm building Angula. Angula is a language learning app focused on African languages. Right now, we support the 9 official South African languages, so not English and Afrikaans, because that's fully covered. And we are in the process of adding Khoi Khoi, which is very nice. So that's me. That's what I do. Cool. Backstory. Why am I standing in front of you today? Well, like I hope most of you, I like to tinker. When most people think about tinkering, they think of this, people working in a garage. I don't tinker like that. My parents say something went wrong and I'm just not good with my hands, and they're so happy that I found software development. So I tinker more like this. Like all of you, I have a graveyard of projects on GitHub. Got a graveyard of hoarded domain names, misspelled ones, correctly spelled ones, for that $1 billion SaaS that all of us have. But I'm also cheap. I don't like to spend money on my tinkering because not all of them are making me money. Angular is close. ZA Tech Radio doesn't make money. So if you go on the website, there's a button to buy us coffee to fund my tinkering. And like that diagram there, in my head, my head is filled with AWS billing facts, because I don't have the time to learn when Vercel is going to start screwing me, or whether Heroku is going to take my resources down. So I've went bare metal and said, you know what, I'm going to work on AWS, but I'm still cheap. So over the last couple of years, I've been working on a stack that is workable, allows me to tinker without breaking the bank. So for front end, like everyone else, I've fallen in love with React.js in all different flavors. So I've used things like Vite, I've used Next.js, I've used Remix, all of that, but it works. And I use Amplify a lot. Amplify, if you're familiar, allows you to basically launch full stack apps on AWS. I don't use it for that. I really just use it to easily deploy my front end, more like how we all used Heroku or now use Vercel. And for compute, again, this was something that was a lot of work for me to try and arrive at a solution. A big fan of Lambda, but like all cloud native solutions, the problem is figuring out how to get it to work locally. Local development. A lot of people rave about developer experience these days. So for me, I landed on Lambda with AWS SAM. I started with SAM, moved away, went to serverless, tried local stack and all sorts of things, back at SAM. It's been a long journey since 2019 trying SAM. It's much more evolved now. But then comes data storage, right? So serverless is great, Lambda, Azure Functions, whatever your flavor is great. But traditional databases are not built for that. There was a solution. So of course, like for everything else, images, your assets, like everyone else, I use S3, which is very nice and cheap. But I had spun up an RDS and RDS proxy. So RDS proxy basically allows you to reuse your connections so that as your Lambda scales, your database doesn't fall over or your app doesn't fall over. But that costs money. So that's where DynamoDB comes in. But bear with me, DynamoDB is a bit of a mind shift. It doesn't necessarily work exactly like relational databases, but it also doesn't exactly work like NoSQL databases. So what is DynamoDB? The simple answer is DynamoDB is a cloud-native, NoSQL, primarily key-value database. What does all of that mean? Cloud-native means that it runs in the cloud, right? It means we don't know. It's running in some data center somewhere. It's not controlled by us. You can't host it on your on-prem data center or anything like that. So it's technology that was built for the cloud, is sitting in the cloud. This is a nice thing, right? Because it means we don't have to worry about all of that. But the local DynamoDB, so basically you can run DynamoDB inside a Docker container, allowing you for local development. It's not quite on par with what's on the cloud because that's proprietary, but the local one is written in Java. You can look at it and all of that, but it works. It does the job. NoSQL, I don't know if anyone actually knows what NoSQL means. So NoSQL was a hashtag a couple of years ago that actually stood for not only SQL, by the way. So it doesn't mean not SQL, it just said alternatives of accessing data, but without using the ANSI, whatever the full definition of SQL is. And primarily key value database is that, like at its core, it is a key value store. So you have a key and you have a value, but you can store documents. And that's why primarily key value, but allowing other things like storing, for example, like a full JSON object. Cool. So how does that compare to SQL? SQL versus NoSQL. Like, why is it important? Why are we talking about it? Why is there a difference? A lot of people will tell you that you can do all those things that you want to do in Postgres, because in Postgres you can also store documents and all sorts of data. So why? Well, there's a few things. Number one, SQL is relational, which means that you have to structure your data in that way. A key example that I use is that as a person, you could have more than one address. It becomes unpredictable because someone could have 3, someone could have 1, someone could have none, right? And SQL does very well at modeling that kind of structure because you just have your user table and then it references whatever another table, has a relationship with another table that will hold address data, allowing you to have one-to-many on there. But NoSQL is denormalized, so it's flat. So those relationships don't exist. This can be a bad thing, can be a good thing. Normally a good thing for people who don't know what the data is going to look like or where the data is not structured. So imagine you're collecting social media posts. You're getting posts from Facebook, you're getting posts from Twitter, and now, if you're lucky enough, you're collecting posts from Blue Sky. It's useful to not really have a fixed data structure in those cases. But a bad thing in a way with SQL is that it scales vertically well, right? So it means that you add more power to to your resources. The problem with that is that it's finite, right? You can only scale up as to a certain extent. And NoSQL, the appeal of it was that it scales horizontally, which means that it scales out. You can add more machines, right? Which is much easier. Well, not as easy if you're managing those machines yourself, but that's where the cloud comes in. With SQL, you're looking at modeling your data around queries, whereas with NoSQL, you are basically dealing with views, right? SQL maximizes for storage, and that's why the hard limit that you can hit, and NoSQL maximizes for compute, right? When you start thinking about maximizing for compute, and you start thinking about how Lambda is basically built on compute, you start to see the relationship that serverless applications have with NoSQL storage. Cool, but is that all? No, right? Like I said, DynamoDB is serverless, which means you never have to worry about patches or updates or anything like that. So you don't actually have to be a system admin to store your data there. It's document or key value. It means that you can model your data in that way. You can really store anything in any kind of column, whatever, like it's not going to restrict you. It's event-driven. So DynamoDB has a very nice feature called streams, which means that data or information about data or changes that happen to your database can leave DynamoDB as they happen. So imagine you want to know if there has been a write or something like that because you care about that, not so much about reads. You can have a Lambda that is basically saying, as soon as this event happens, trigger something else, send an email, update a spreadsheet or something. Excuse me. Because you can scale horizontally, DynamoDB is also built to scale to any load, right? Like any load. You can be building an app like me that is just a hobby project that never becomes something, but in case that becomes something, you can still use the same underlying data store to scale up to millions of users, which is great. The other part of it is that it's consistent and fast, meaning regardless of whether you're serving just yourself, the one consumer, or millions of people, like it's the same speed. Doesn't matter how big your database grows, you're getting the exact same speed consistently over and over again, which is very attractive. And another one, a friend asked me the other day, he wanted to model, if you use an iPhone now, if you try to access your photos, it's going to ask you whether you want to just allow access to one photo or not at all, or to all photos. And DynamoDB allows a similar kind of thing where you can define access at the table level, items, attributes, and values, and we'll speak about what all of those are. Cool. A bit of history. DynamoDB was built by AWS, and it's actively used by AWS. In 2007, they published a paper. It's a very nice paper to read about the problems that they were trying to solve. So all of us, if you work for a retailer, you know what Black Friday is like. They had to solve similar problems, and it's all covered in that paper. One of the authors of the paper is Amazon's current CTO, still active CTO, which is quite impressive for me. And they've been using DynamoDB from day one, and they still use it today. So the Amazon shopping cart is powered by DynamoDB, and that's why they don't have issues regardless of the amount of surge in traffic and things like that. So it supports Amazon, should be good enough for everyone else. And it gained general availability back in 2012. Cool. One thing that I said, it's managed for you, right? So you don't have to worry about hardware provisioning. If you've ever worked in ops, you know what the procurement process is like. You usually overstate how much resources you need because you know how long it takes and things like that. You don't have to worry about that. You can scale up or down as you need. It's got cross availability. So it replicates to whatever availability zones you actually want to access. It's got built-in monitoring and handling of failures. So you don't call DynamoDB directly like you would with a SQL database where you just run queries against it. It comes with different SDKs. So basically just packaged ORMs. So Boto for Python, and like I think they're available for all there's something Object Mapper for Java and things like that. And what those SDKs also have built in is things like, what do they call it? The back off algorithm thing. So if it fails, it exponential back off. And like I said, they manage the patches, the updates, and fixes, so you just use the database. Cool. Another nice thing about it, and this I want to put a disclaimer. DynamoDB can be expensive depending on how you access it, but we're having this conversation, so hopefully all of you digit millisecond latency for put and get, so for writing and reading. And this is for any database size, right? Imagine single digit millisecond latency, regardless of whether you're serving 10 people versus when you're serving a million people. And this is enabled by custom SSD like platform. So that allows that performance independent of the table size. And that's because there's no need for the working set to fit into that specific memory. So you don't hit those kind of like upper bound limits. Remember, it's optimized for CPU. So what are some of those use cases? The thing we're talking about today, rapidly prototyping an idea. You might be the next Mark Zuckerberg and you have an idea and you want to try it out. So it's very good at doing that because you don't have to go provision a database or even spend money on anything like that. And because of the scale and the performance that it allows, it's built for high volume transactional requests, so reads and writes. And like I said, it's used from day one by the Amazon shopping cart. It's also used by Duolingo, not sure to what extent. And it's also used by Netflix. If it's good for Duolingo and Netflix, surely it's good for you. When not to use DynamoDB, because I think it's good to know when to use it and when not to use it. So the good use cases, again, you're talking about simple like key value queries. Imagine you are doing something like managing people's sessions. You might be using something like Redis, which is, I think, if I remember correctly, faster. But some people use their relational databases for things like session storage, which is not great, right? You can use things like DynamoDB for that. If you guys are familiar with Terraform from HashiCorp, you can store logs. So with it's not a Terraform talk, but yeah, you can store logs in DynamoDB. It works very well, scales easily as well. Like I said, if you have very high read or write kind of workloads, works very well. If you want consistently low latency, because again, the latency that you're gonna get when you have 10 users is the same latency you're gonna get when you have 1 million users. So if you want that predictability, it's a very good use case for that. And if you don't have any size throughput limits, then that's a good use case for it. But there are bad use cases for DynamoDB. So if you're planning on writing complex queries and joins, like as you do from a relational database background, and DynamoDB is not built for that. If you want to do things like real-time analytics and queries, and I have tried to do this in the past and got burnt, that's not what the use case for. I think to summarize it, it's good for online transaction processing kind of workloads, bad for analytics processing. Cool. So what is the structure of DynamoDB? It's actually quite simple. I think of it as 3 scalar types. You've got string, number, and binary. And then you've got the list versions of that, so sets. You've got a string set, you've got a number set, and you've got a binary set. That's all you need to remember. String, number, binary, and then just a set for all 3. And what enables DynamoDB to act the way that it does is how it does indexing, right? So your data is indexed by a primary key, which means that data belonging to the same primary key is likely to be stored in the same place, right? Meaning that when you retrieve, again, that's how you can kind of guarantee that same kind of latency. So like in relational databases, in DynamoDB, you've got primary keys, but it works a bit differently because you can just have your primary key being a partition key, also called a hash key. I really don't know why there are 2 names for this, but people use them interchangeably. So partition key is the hash key. But you can also have what is considered a composite primary key. So that is your hash key plus your range key. So partition key plus a sort key. Cool. Why? Because if you just had a partition key, excuse me, you would need to have your values in that, basically your primary keys to be unique, right? So if you were to model something like this where you wanted to have the artist, the album, and the year, you see Kanye West is repeated there. If you just use the partition key, you couldn't do that. but you might want to store your data in this way where, you know, it's artist versus, next with the album next to them. And to model that kind of storage, you would need both the hash and the range key. And we'll get to why this is important going forward. Cool. So this is the anatomy of a DynamoDB table. So you've got your primary key, which can just be the partition key, which is required, or you can have a mix of the partition key and the sort key, making a composite primary key, but the sort key in this case is optional. And then you've got your attributes. So your attributes, you're talking about things like whatever like in this case, like product and type and things like that, or the albums, the genre and things like that can be your attributes. So your attributes, you're thinking of your columns. And then when you talk about your item, you're talking about your complete row. And as you can see there, that is one table storing different things. So there it's storing books, and that's why that one is book ID, storing albums, storing a mix of the album ID and the track ID, also movie. That's because DynamoDB scales infinitely, a common use or pattern that people use is something called single table design, where you use one table to almost store all your data because it doesn't have to be related and you don't have any limits. It is a different way of thinking. But important to note is that there are two ways of querying a DynamoDB table. One, I state here of completely, so it's considered a scan. So a scan will read your entire table, and then it will apply a filter expression for you to get the data that you want. A query will go and fetch the specific data you want. The reason why is because for you to do a query on DynamoDB, you can't do like a select all where. You have to basically say, give me the data at this partition. So give me the partition key or the partition key and the sort key to retrieve the items in that range. Identifies a single item, as I said. You can think of it as an unordered hash index because you don't need to know how the hashing works, but you must know that there's a hashing algorithm. So for whatever you've chosen to be your partition key, that gets hashed and that gets stored. And that's why data that belongs to the same partition will be stored together. And this allows DynamoDB to scale very well. And then with the sort key, so this is using two attributes to uniquely identify one item. And in this case, the items are arranged by the sort key. So for example, if we go back to the example of the artist name would be your partition key, and then all the albums would be the sort key. You can really have anything else as a sort key, but that it means that all their albums would be stored in the same partition as the artist information itself. So basically all data gets kind of stored together and making it easier and consistent to retrieve. And there are no limits on the number of items per partition key in that case. So you can have repeated information like Kanye West was in that other example that we had. Cool. A very important part of DynamoDB, because again, you can think of like needing to know the primary key in order to query the data is feels limiting. So there's a feature that allows you to kind of have a bit more flexibility, even though it's still a bit limited. And that feature is called indexes, work like indexes in relational databases with a bit of a difference. So you've got local secondary indexes and you've got global secondary indexes. The difference being a local secondary index can only be created when you create the table. And we'll cover this later about how when you work with DynamoDB, you kind of have to have an understanding of what your access patterns are going to look like. So the data modeling with DynamoDB is kind of not as emergent as it might be when you're using relational databases. The other difference is that, so when you have a local secondary index, it means that you have the same partition key, think artist, but you might have a different sort key, right? So you might have in your table, you have the artist, and then you can have maybe the album, and then maybe you want like the year the album was released as a different sort key, and you can use a local secondary index to do that. Again, it's like a lot of pressure for you to need to know what your access patterns are going to look like. But if you look at this example here, where we want to get items. In this case, we have our country being the hash key. So we say, okay, fine, we know the country is France, and then our sort key is the scientist, and we say, okay, fine, we want a scientist whose name begins with Marie. So highlighted there, those are the two parts that will be hit, your hash key and your range key. But if you have a local secondary index in this case, so if you look here, you want to have a country with a, like sorted by the scientist. But let's say, for example, you have another use case where you want to sort by year. That's where you might use a secondary index where you say, fine, anything after, so like scientists from France, like who were born after the year 2000 and things like that. So in that case, your year becomes the range key for the index, even though the scientist is the range key for the table. So that's the use case. But again, that's very limiting. You do have another approach, which is a global secondary index. So a global secondary index, that is like an index across all your different partitions. What this enables is that you can have a different partition key and a different sort key if you want. Another approach that gets used a lot here is people make use of composite sort keys for something called compounded indexes. So if you think about the country thing, you can have a whole other field in your index that has like scientist and year or something like that. So it enables some like nice and very strange access patterns. So here's our example where we might be using a table without a global secondary index, where we are searching for an artist. Again, remember, you need to know the hash key, you need to know the primary key. So we're saying, fine, give us anything by AC/DC ordered by the song, right? So whatever ascending. So in this case, you'd be hitting the artist or the song. But you might have another use case where, for example, you want the album to be your hash key in this case, right? As opposed to having to know the album. I mean, having to know the artist, you know the album. So in this case, the album becomes the hash key, and the song can still be the range key, or you could use year, right? But this does come at a bit of an extra cost because it allows this kind of flexibility. Cool. There are limitations. Some of them can be deal breakers for you, some of them not so much. An item, think of a row that needs to have a max size of 400 kilobytes. It's a hard limit. There are ways around it, but I think that's a bit like way more advanced. You can read up on it if you're convinced on DynamoDB after this. You can only have a maximum of 5 local secondary indexes. And your items that you store, again, remember you can store documents. Those documents can only be up to 32 levels deep. So if you have anything that requires more levels, it might not be the thing for you. And then in terms of read and write request units per table, you've got a maximum of 40,000 reads and 40,000 writes. Those are capacity units. A nice bit of homework is if you're looking at writes, so you have strongly consistent writes, strongly consistent reads. Writes are the same. Strongly consistent reads and eventually consistent reads as well. So those have two like different implications. So if for example you reach that limit of 40,000 for reads, you can kind of get like twice as much read out of it just by switching from like strongly consistent to eventually consistent, if that works for your workload. And there is a table limit of 256 tables per account per region, right? Meaning that you can basically have your DynamoDB tables in other regions. Cool. So that's all good and well, and I hope we're still on the same page. How do you model or do you query all of this? Because it is as strange as it sounds. I've tried to make it less strange, but it is very strange. Cool. So let's consider like the steps. So for me, these have been very reproducible steps in working with DynamoDB. Number one is consider your use case carefully. Number two, access patterns become very important. So you need to be aware of your read and write workloads. You need to think about your query dimensions and aggregations, because otherwise you end up having to do scans, which are very, very expensive and can also hit other limits. And then number three, it's doing the data modeling. And the most difficult part about modeling the data is avoiding the patterns that we've all learned from dealing with relational databases. And again, it's not a bad thing to use a single table for all your data, regardless of the different shapes. Keep that in mind. Cool. So when considering the use case, I think what's in right now is delivery services. So it could be delivering food, all sorts of goods. So think of the business model. Customers want stuff, and we get them stuff. That's our business. So how does it work? People add stuff to lists, and then we drop off those stuff when and where they need them, right? That's how we would model it. Normally, you'd start with an entity model to see how does this work. I have omitted a lot of the details in terms of like what fields the vendor, the customer, and the driver would have, and kind of kept it simple. It's simple. Customer places an order. An order has items. A vendor accepts that order, meaning makes those items available, and the driver delivers the items, right? Simple enough for all of us, right? Cool. So that's the business case. What are the access patterns? So what you might not have to think about normally when you use relational databases is, you know what, I'm just going to select stuff from here. Maybe you might think of foreign keys, or you'll add constraints later and things like that. DynamoDB is a bit different. You kind of have to think of this stuff like upfront. There are ways to get around it. I mean, and also what I recommend, which some people might not like, is that really if your access patterns change drastically, you could really just copy your data, replicate it to another table, right? It's not the worst thing in the world. But for our example here, we might think like get orders. So we might want to get orders by date range, by the customer, and by the vendor. So we consider that in how we model our data. We might want to get the order details. So we might need to know the status of the order. Has it been accepted? Has it been delivered? Those kind of things. We might also need to know like what items belong to that order. Getting deliveries, we might want to get deliveries that happened within a specific date range. So give me deliveries that happened in the last 3 months. Maybe we want to compare it to deliveries that happened in the last 6 months or something like that. So date range, or you can say, okay, fine, I want to see the deliveries made by a specific driver. You might also want to get available drivers. So this would be like by geolocation and time. So if I'm ordering my goods, my stuff from Midrand, you want to get a driver that's close to me and things like that. And of course, that data might be stored in DynamoDB, and might also want to get customer data. You want to know who I am. You want to know all sorts of details, and might also want to get the vendor data, who they are, the email addresses, and things like that for various reasons. So that's it for our access patterns, right? So remember, use case, access patterns, and then actually modeling the data. This is not what an ERD looks like. Again, I've omitted the details. Like there would be things like many-to-many and all of that stuff that you might think about. But like ideally, this is like what ties the whole thing together is the items, because the customer will have a relationship with orders, for example. And a vendor would have a relationship with the items because they need to accept them, so changing the status of the items. And the driver has a relationship with deliveries, right? And deliveries, again, have a relationship with items. And this might be the way that you think of it in a relational manner. And please brace yourself, because this is how you might model it in DynamoDB. Right? So that's that single page like design again. So these attributes, I have put them like you don't necessarily get them like this. So you might find in places where you've got like an address for a customer, but you might have an address as well for like a vendor and an address for a driver. Or else you might have a status of an order. You might also have like a status for like a GPS device or something like this. So I know it does seem strange, but like this is the kind of way that you start to look at your data. You start to think of it initially from like, okay, cool, this is my partition. So if you look at the hash key here for the customer, you can use like the customer's email as your hash key, and you can have multiple sort keys. So you can have the date that the customer joined, but you could also have like the actual key, like customer or whatever like that, as a sort key, because, for example, you might have an identifier that will identify a driver, but that identifier will also tie the driver to like the GPS device that they have and things like that. I hope this was exciting, because that's it. So that's DynamoDB in a nutshell. Any questions? Yeah.
With regards to like consolidating the data into one table, I'm like assuming a lot of risk with regards to manipulating the data, or like it's usually want to keep eggs in this basket, eggs in this basket, so that they don't smash and break and stuff. Like, are there any concerns from your perspective with regards to having these different data structures within one table?
Cool.
I'm just thinking about potential use cases. It's very easy for someone to mess up everything, where it could have just been potential items or just potential, what we're working on at that time.
Cool. Yeah, look, I think just repeat the question for those on the stream. I want to know if there's any dangers of having your data stored in one table. I think there's a lot of material out there on. There are some people who are for single table design. You're not restricted to it. You can do it in multiple tables, but then like that means that you would need to know like the partition key for like that table and things like that. And DynamoDB does have transactions. If I remember correctly, I think you should be able to do them across tables. I'm not really sure. I'm more on the single table design. No, I don't think there's like, I've never really run into an issue, because you can have like a fine-grained access control as well, and also you get snapshots and backups and things like that of your data. So not really much concerning. And the way like that you deal with DynamoDB, like you usually access it like via API. So you might say, okay, fine, for your dev environment, like it's really quite safe for people to do whatever. And then for your prod environment, you might have like more elaborate checks in terms of like your code reviews and things like that. Cool. I hope that answers good. Yeah.
Just want to reiterate the comment, see if I'm thinking this correctly.
Yeah.
If you mesh all this data,
yeah.
So you have the option to create multiple tiers.
Yeah.
So that you can keep track of the different data sets.
Okay, yeah, so again, repeating the question for the stream, person here wants to know if they have to create multiple, well, whether you have the option to create like multiple global secondary indexes. So you can. So the way you think of your GSIs is like about access patterns, right? So if you think about initially, because to run a query, we want to avoid scans, right? Because they're extremely expensive. So you can write scans, and like it will return all the data, and then can use a filter expression to say, give me data that kind of conforms to this, but it's going to read your entire table, which is extremely expensive. So you want to lean more towards a query. And also there are limits to the number of items you can read and things like that. So your global secondary index is about you uncovering after the fact, like a different way for you to be able to access that data. So instead of saying, I need to know the artist in order to get to retrieve the data from my table, is I know the album. So I want people, for example, if you're building something where like you want people to search for a specific album, they can search for that. So they don't just have to search for artists. So because GSIs can be added after the fact, how you want to think of it is like your core access patterns, you want to kind of map that against your table directly, and then use local secondary indexes for that. And then only when you have very unique access patterns do you want to start thinking of global secondary indexes, because they do cost a bit extra. Yeah.
So you can have multiple.
Yeah. Yeah, and you can, so you can delete like global secondary indexes if you don't need it, and create another one and things like that. Can't really do that with the LSIs, yeah. Yes.
I've got a question here from the live stream. What is your opinion on simulating a relational database by doing multiple queries to multiple tables?
Look, I think that's an anti-pattern in my view. I have been guilty of a similar thing. So I've got a bit of a story. When I started venturing into NoSQL databases, I used Mongo and I used Mongoose, and I started trying to do transactions, which were kind of like, that's not the way. And that for me kind of gave me the indication that maybe I'm using the wrong tool for the job. So I think I don't know, if you have an edge case and you're doing it something like that and you don't want to remodel your data yet, sure, but I'd stay clear of the relational thinking when coming into like working with DynamoDB. I would really encourage you all to kind of like learn about single table design, because DynamoDB is ACID and you can write transactions. So for example, one of the things that I model a lot in my data now is like constraints, because you don't have constraints, right? So I might do like multiple reads or even writes in a transaction with a key condition. So let's say after writing something to a table, I'll also write something else to indicate that that item has been written. And then again, in my transaction, I try to write those two things, and that other one will fail. So you do have some similarities, but if it's like too out of the way in terms of how DynamoDB works, like out of the box, I would try and avoid that. I hope that answers the question. Any other questions?
Is there a plugin to use SQL?
So there is actually like a query language. I've never really used it. Rian, maybe you do know, on top of DynamoDB, that is SQL-esque. So you can do that. And also there's a JavaScript thing as well that kind of like lets you not worry about any of this in terms of single table design. I forget. I'll ask Rian to send it as an email, but there are a lot of tools and a lot of attempts. You know that developers are trying to make DynamoDB SQL. There's definitely like a lot of attempts out there in the world. Cool. Thanks, everyone. Oh, cool. Yeah.
So is it well documented, like in terms of how they expect it to?
Yeah, it's well documented. So just to repeat the question for everyone on the stream, is DynamoDB well documented? Yes, it is. Not primarily by AWS. So AWS documentation, people have opinions, but it is something that is widely used. So like there are like entire companies that have spawned with just the focus of building interfaces for DynamoDB, and that kind of documents it. There's a lot of documentation on things like single table design, on things like transactions and access patterns and things like that. Like easily, you go on Google and you say DynamoDB getting started for Python. People will have written a lot of articles around those specific SDKs that you can use.
I noticed with the tech stack.
Yeah.
So that's like
Okay, cool. So question there that was just asked right now is that in my tech stack, which I showed in the very beginning of the slides, there's a lot of AWS that has DynamoDB. Tie me down to that? No. So I don't buy into the vendor lock-in thing. I think it's quite easy for you to detach yourself from a vendor. The technology is called containerization. We all use it. There's nothing stopping you from containerizing an app, deploying it somewhere else. What I have found is that for my hobbies, when I try to, I found AWS to be predictable because I've invested a lot of time into actually learning. So it's not really that hard for you to migrate, because like you can basically export all your data from DynamoDB and import it somewhere else. I just opt towards DynamoDB because AWS, because they've got a very generous free tier, and in the past when I've compared it to other clouds, like tooling like Lambda and S3, I found it to be cheaper. So I usually gravitate towards it because I understand like how it's going to hurt my pocket. But it's by no means a prescriptive tech stack. That's just for me. When I spin up a project, that's my tech stack. Yes, another question?
So you mentioned that DynamoDB scales infinitely.
Yeah.
So I know this is an unlikely scenario, but let's say the whole world population isn't going to scale.
Yes. So the question that was asked, I'm being called on my infinite scale of DynamoDB. Yeah. Look, I think they like. I guess like until like you'd have to do a calculation of the number of computers, people in the world, and what things like that. Like as long as you can put an extra computer, an extra data center somewhere else, and I think we kind of, it would be up until the limit of the computing hardware we have available to Amazon, I guess. But the idea is that like, I mean they do, I think it's 99.95 availability for DynamoDB. With all sorts of people accessing it in all sorts of ways. So never really like heard about an actual like a huge issue. You do have cases where like a data center might go down and things like that, but that's where you have multiple availability zone, redundancy and things like that, and you don't have to worry about it because it's managed for you. Yes.
You sort of mentioned something that brings to my mind. So in terms of managing sort of redundancies of the data,
yeah,
or is that managed for you don't have to ever worry about it?
Yeah, so the question I was asked now is about redundancy and you having to manage that. Look, AWS has a lot of options of things that you can think about, but I don't want to fib. There are some defaults that are coming in now, things like, what do you call this, like your encryption and things like that come as a default. I think that replication comes as a default, especially when you do like pay as you go, so you're not provisioning any specific resources and things like that. Then it will scale for you because you can go and say I want to provision this much like reads or writes or whatever on my database. So once you start hitting those limits, you're gonna get errors. And if you're using the SDK, it's going to do exponential back off and try for you. But as much as I know, like things like redundancy, replication, they handle all of that for you. You don't have to worry about that. Question?
It's more of an answer. I'm just going to answer that question
Yeah.
about how DynamoDB scales.
Please get the mic there for the stream.
Just want to answer the question about how DynamoDB scales. So there's a white paper that I think I sent to you, VT, a few months ago, and the entry of this white paper shows that how Amazon has used DynamoDB internally. And in 2000, so basically I'm going to quote, in 2021, during the 66-hour Amazon Prime Day shopping event, Amazon systems, including Alexa, the Amazon.com sites, and Alexa fulfillment centers, made trillions of API calls to DynamoDB, peaking at 89.2 million requests per second, while experiencing high availability and single-digit millisecond performance. So that's 90 million requests peaking and still getting a single-digit thing. So that's how it scales.
It's a lot. Cool. Thank you all for coming to my TED Talk.
Also, just to add to the scale of like what DynamoDB is, like I once spoke to this guy that actually worked on the DynamoDB team, and he also worked at NASA. So we talked quite a bit about both stuff, and he said that his work at DynamoDB was actually more mission critical than his work at NASA. Because if DynamoDB goes down, it's like S3 goes down. Half of the internet is not going to work that day. That's how mission critical and how critical DynamoDB is to AWS and actually like the whole internet, like at this point. It's like massive scale. VT, like thanks a lot for your talk. It was great. And for Tangent, like for hosting us. We are going to go next door now. I think the pizzas will be arriving very, very soon. Uber is a little bit late, it seems. And then we have some swag over there as well. We can network still for the next half an hour. You guys are welcome to stay or to go. Thanks for coming, everyone. Appreciate it. Bye-bye.